Hi, welcome to the latest webinar in this virtual event series for the Cloud Security Alliance. I'm Dr. Christopher Porter, Head of International Security Cooperation for Google. So I set up our intelligence sharing partnerships with governments and our largest, most mature private sector partners around the world. And I wanted to talk to you today about AI, cyber threats, some defensive, some offensive. But, most of these kind of webinars or talks that you go to, keynotes, people talk in generalities. I'm as guilty of this as anyone. I'm kind of I say a big picture thinker, but it's often just easier to speak in generalities, right? So I thought, give you something a little bit different. Unless you work at one of the hyperscalers that is running its own frontier model and also has a cloud service, and in Google's case, we also own 25% of global internet infrastructure in terms of cabling and data centers. Unless you have all of that, it's really hard to do anything even remotely quantitative. So I wanted to talk to you a little bit today about the numbers behind AI cyber threats, offensive and defensive, give you a sense really of how bad certain things are or what scale solutions are being implemented at. This will be some of Google's proprietary research, but I've also got a lot of material in here from Meta and other companies as well, from their academic research generally or their public research. These are just studies that I find really useful for shaping my own thinking. So I wanted to share those today. The first thing, I often kick these off this way, so apologies if you've seen one of my other webinars, but why should you believe anything I say? Like, how could somebody in the private sector possibly know all of this about adversary APT groups and so forth? Well, besides owning 25% of global internet physical infrastructure in terms of data flow, that's how we're measuring that data flow. We do every level of the OSI model. So from the physical level up to running the cloud data centers, up to the applications on your Android phone, the App Store. Obviously, many of our customer or just public-facing services, Gmail and Google Drive and so forth, also have seemingly endless users. On the Mandiant side, we do a lot of incident response. So going in and kicking the APT groups out of these kind of high security environments that were difficult to penetrate in the first place. So these are high skilled groups that we're kicking out. We do over 1,000 of those a year in 60 different countries. So I want to talk in just broad terms about what Google is preparing for short, medium, and long term in terms of AI threats. But really, I want to get to the numbers behind these estimates. So when we think long term, as an intelligence analyst, long term to me is, longer than a couple of years. So let's say 3 to 5 years, certainly no more than 5, but really this is just 3 or 4 years. On the offense side, much like any other kind of intellectual labor, white-collar work, there's a lower barrier to entry. That doesn't mean that every APT group will suddenly be world-class. Just like if I use an LLM to play lawyer or doctor or accountant or, psychologist or whatever, hopefully they're not as good as the best people in those fields, at least not yet, but they are reasonably good. And so I think that's kind of what you'll see in cyber as well, reasonably good offense. You'll also have, though, the ability to, respond at scale on defense. So the next time there's a 0 day, if you're in the cloud, you already have a pretty good inventory of your equipment. The ability to patch and update hopefully shrinks the response window. That's where I think the equilibrium is. A world full of good enough threats, but it's harder to get in because there's, less sort of technical threat surface exposed in the first place. The threat surface is probably mostly identity, tricking people into giving up their creds and so forth. But there's very little, hopefully, technical threat surface exposed compared to an on-premises environment. And to the degree that there are exploits, maybe you can get some victims, but they're quickly patched. Okay. What about if you're running the sort of corporate team planning side of things? What should you expect? Well, what you're really going to get in the long term is that the doing of the work, yes, experts will still be valuable, arguably more valuable than ever, but the average, person on your team, what you're going to need them to do isn't the sort of implementation they're doing today, right? If they're working at a SOC or they're a threat intel person, the doing of the work of the analytic work isn't necessarily what they'll be spending most of their time doing or what you're going to hire for. You really want to train people to hire for judgment, what questions to ask and what to do with the answers that you get. So what does this look like for us defensively at Google? We've increased our ability to sort of, provide fuzzer coverage for open source projects. We also scan common or popular open source packages for our enterprise customers. So we don't own them or control them or vouch for them in that sense. But when you spin up something on GCP, there's these popular open source packages that essentially many enterprises need. We don't want, our customers to inherit security problems, supply chain problems. So we scan those packages. What an LLM lets us do is it's not doing the actual fuzzing, which is where you take sort of you're throwing data at the code to see if it generates an error in a useful way, just seeing if it crashes in a way that might be exploitable. We don't want to just throw random data because you could do that infinitely and never find anything. We want to take a smart guess about where to look in the code and what kind of data to format. Usually, that's a very highly skilled human doing that work. And for the most sensitive packages, we still do have people doing that. But for most packages, we've been able to increase the number of critical open source packages we cover 30%, now up to 272 C or C++ packages that we scan. And because we scan them, you can automatically install them as part of GCP. The total amount of code that we've increased has gone up 7,000%. And this is with the same amount of compute. We haven't increased our total resource commitment to this. What we're doing is using the LLMs to take smart guesses about where errors might be generated. Look at the code, look at the syntax, and help us come up with some guidance for the fuzzing tool. In this case, we increased like the coverage of OpenSSL, I think, almost 50%, which is tremendously important in terms of systemic security. Medium term, so not this year, but not 3 years from now, somewhere in between. Probably a broader array of actors finding 0 days. I'll talk about why I think that, because we're finding them at Google with AI. The kinds of 0 days you find, the proportion will probably also change over time. It's a little outside my expertise, so I'm not going to be totally confident in that, but there's a lot of good research on the fact that LLMs are sort of superhuman at finding syntax errors, right? If you just mistype a function and that's exploitable for some reason, probably the LLM is going to find it. But logical or stateful errors, so buffer underflows, buffer overflows, or even more complicated cases where the code just gets into some edge case that the developer didn't plan for or intend, that requires a lot of memory and the ability to imagine. And it's not that AIs can't do that. They do find them. In fact, the examples I'll give you today are those kinds of errors. But the AIs are just so good at finding the syntax errors. I think in the next few years, you'll see compilers and other developer tools automatically using LLMs to scan, your code for these syntax errors. So hopefully they're eliminated up front. Or companies like ours are scanning the open packages and finding them first, hopefully. Maybe not 100%, but that proportion of 0 days will change over time. At an HR level, it's not a quantitative thing, let's say, but if you have multiple senior people on your teams, any kind of security team, you got Bob and Susie, and they're both kind of the senior leaders on your team, the senior substantive working level leaders on your team. And Susie learns AI tools and incorporates them into her workflow, and Bob doesn't. Maybe it makes a marginal difference in the first year, but over the next 2 or 3 years, it'll make a huge difference. Susie will be doing 10 times the work that she did in 2025 in terms of output. Bob is still doing 1x. And even though it's expert work, that will naturally shape promotions and so forth. It's something you really have to encourage your teams to do for their own good, frankly, is to, even the more senior folks, to really learn these AI tools. I would not have included that as a prediction or a recommendation 6 to 9 months ago. I've just become convinced from what I've seen in our own teams and in how the tools have developed and how I use them in my own work. I think they are going to be multipliers for high-skilled people. So Google found a 0 day. This would have been a worldwide problem. It's a stack buffer underflow in SQLite, which is a widely used open source database engine. So how do we do this? Well, we had one of our sources, one of our human sources on a criminal forum telling us, hey, we're planning to launch a 0 day against this package, in the near future. So we knew to look for it. We knew for a fact that there was something to find. And we also had some good guesses that we could give the LLM based on other security problems that researchers had found publicly. We had a good guess of where to look in the code. So the fact that we're doing that, Anthropic has had impressive results finding errors. Microsoft has had some results. All the major, providers and users of AI are telling you, we're finding more and more and more vulnerabilities this way. That is something I expect people to be able to imitate on offense as well. How did we do that? Why are we doing it now instead of, say, 2 years ago? It's not just that the AIs themselves are better trained or smarter. They are, but the big leap is in how you design them. Don't just have the LLM do everything itself. Have it use the kind of tools that your current real-world team does. Have them use the debuggers and browsers and so forth. The built-in, reliable, professional tools you already have. Having an AI-controlled tools keeps their context window smaller, gives you less cumulative chance over time of failing. So if you think about the phases of thinking, you have to do multi-step thinking. The real difference between the sort of fast models and the more powerful frontier models is whatever AI provider you use when you turn it on max mode. The real magic is that the higher level model continues to succeed at each phase of thinking. Maybe it's a little bit less successful each phase, but it's marginal, low single digit percentages of getting off track. The fast models, when you ask them to do thinking 7 to 10 steps or more, you start getting 10, 15% rates where they just get down a corner and they can't get out of it. That takes different forms depending on what the question is or the task, but human beings can reason from a very small sample set of lived experience. If you go up to a door and it's locked and you can't open it, you really just need that one example to sort of think through how you might open the door. A lot of the AI models, even today, require thousands of examples of, in order to learn from it. So if you extrapolate that, you give these PhD level deep thinking models, they're superhuman impressive in some ways. The problem is when they do multiple steps of thinking, if they get stuck on one phase and something doesn't work in what they're doing, they're less good than humans at sort of getting themselves unstuck. So you want multiple agents, each with their own tools. If they get stuck, hey, the big sort of essentially middle management agent at the top can restart that LLM. What does this architecture look like? This is success rate attempting to do a buffer overflow. This is old data, a couple of years old, but it should give you a sense of what a big difference this architecture makes. So don't worry about the literal model numbers, but just look at the same model numbers using this kind of agentic and tool use, using tools instead of having to do the whole thing themselves. Look at the success rates, on the same problem. On the x-axis, you're looking at attempts or like stages of reasoning. The y-axis is success rate. You get very marginal improvements even with the more powerful models. They're getting maybe a quarter of the time success rate, the old Gemini model. They all essentially go to 100% once you give them this new architecture. So don't take my word for it. That is how to design things for offense and defense. Since long before I've worked here, we've used what we would have called machine learning to fix bugs, to find bugs, and then you'd have humans fix them. And we have at least two people. So one person commits a code change to fix a bug, another person has to accept it. But 15% of the time, we can have an LLM, an AI, fix the bug that is identified. So not just finding it, but actually rewriting the code. These do tend to be simpler bugs. But if you think about assigning a software developer to work on a piece of code to fix it, whether it's hard or easy, a lot of your time is going to be spent in overhead, loading it up and opening the ticket, and when you're finished, filling out the paperwork and blah, 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 blah. There's a lot of overhead, and then there's the work. So yes, they're easier, but still 15% increase in time. Nobody has enough technical people, not even us, even though we have many thousands of them. Nobody has as many as they would like. And being able to get a 15% extension of your team, that is a reasonable outcome that you could be doing in your organization. Like that is a reasonable, to the degree that you're developing software, that is something that you could replicate with existing tools. That's not something that is unique just to our organization. In the short term, meaning this year, imminent, any day now, I'm really worried about the next 0 day. If you think back to the Hafnium and SolarWinds incidents, you had more than 10,000 victims in each case, global exchange servers, global SolarWinds servers, control units. If you think back to that, maybe in the case of SolarWinds in the U.S., you had several dozen government agencies, maybe worldwide, low hundreds of victims. Hafnium, the exchange server vulnerability was broader. There were, not just over 10,000 victims, but there were many that were exploited, but most people were not. Most servers were compromised. Most SolarWinds control panels were compromised, and nothing was taken or destroyed. I think the next time a big APT group gets a 0 day or quickly adopts an end day that's valuable, they're going to get 1,000, 10,000 victims, and maybe they still have their human team on keyboard exploiting the most important ones, but they probably also have a lot of it being automated. These systems are good enough now that, especially if you have access and you're not trying to do the whole operation, you're just doing a few phases, like grab whatever documents here have scientific intellectual property or business competitive insights or military or diplomatic intelligence. They are good enough to do that kind of automated exfiltration of systems. So why not exploit them if you're going to get access anyway? Why not go ahead and take something? So the damage of future 0 days could be greater in real terms because you'll have fewer unexploited targets. I don't know that everyone will do that, but that's an option that will be available to APTs essentially now. On defense, we're already doing this to a large degree, which I'll talk about, but you will see more and more of the routine cyber threat intel and even SOC work being either agentic under the command of a person or certain aspects of it being automated. That'll mean quicker responses. It'll mean you can do more work with the same number of people. It will also mean that for your employees with quantitative, expectations in their performance review, I mean, we're doing this already at Google Threat Intelligence. If your job is to write 10 reports, in 2024, we're probably telling you to write 50 to 100 this year because you're not actually having to spend as much time drafting. So, what has been seen in terms of getting an AI model to automate offense on its own, not assisting a human, but actually completing security challenges on its own. This is research that we've done. It's an older model at this point, Gemini 2 Flash, but I just really want to give you the general shape of the problem, even with this dated model. Being able to do different phases, you can see the success rates vary greatly, but also in terms of what kinds of problems. The easiest problems it solved 100% of the time. The hard problems it solved, high single digit percentages. So a pretty quick drop off depending on how hard the problem is. Malware development, telling it to develop malware, maybe a 30% success rate. Avoiding detection once you're on network, maybe a 40% success rate. Vulnerability exploitation at the time was still very low. This is automated, no human guidance whatsoever. The parts that were more technical, that required less judgment, find a vulnerability or we already have a vulnerability. Now I need you to develop some malware for it. Go ahead and take this document off network that we found. Those had the AI didn't have to generate such long sequences of perfect code. They could make some syntactical mistakes themselves. So being able to recover from a syntax mistake that you make, or if you're on network and the network isn't set up in a way that you experience, these are things humans can quickly hypothesize about and get themselves out of a blind corner. Much harder for the AIs, right? What we would have predicted, which is that this would be good at generating spear phishing emails for, outside of your host country language, weaponizing things that, you can learn from a textbook. And we have lots of examples of this group affiliated with Iranian state sponsored espionage, more successful than, say, data exfiltration. Now, why is that? Why did the earlier thing show that the individual phases were higher? Well, because this is cumulative. We're saying start the operation, do the reconnaissance, and get your way in. As you can see, as you do multiple phases together, even if the individual phases, as I mentioned earlier, exfiltration had 40% success rate. Well, why does it look worse here than recon? Well, because as you go along, you're multiplying those probabilities, right? You have to do multi-phases, you're going to run into problems. That's why the successful automated offense looks a lot like what we've seen from Anthropic and others, where you do what we do on defense and you break it up into multiple phases. Iran also one of the top users of Gemini. 30% of the users, they can't create offensive malware or do any of the kinds of criminal things that you think of. They're mostly using it for language translation, doing basic research on network vulnerabilities, or conducting essentially the kind of Google research that you could do with an old school Google search. They're prepping the battlefield for their cyber operations. We do see on the pure, crime side, these are scams, targeted attacks against wealthy individuals in particular, up 40% year over year from 2024 to 2025, much larger number of successful deposits. We're talking in the hundreds of billions of dollars in terms of the global scam ecosystem, mostly originating in Southeast Asia, but it does happen all over the world. The ability to speak, and this is, essentially you're sending someone a text and trying to convince them to transfer money is what most of this is. Being able to do that in a native language with also with the right accent and so forth, people are just not prepared for it. It's really powerful. What about prompt injection? If I hand over an agentic task to an AI, how do we use this at Google? Well, my profession, I'm an intelligence analyst. So the AI models are not as good as the best humans at doing malware reverse engineering. If it's really important, you still want a human to do it. But for somebody like me as a generalist to get a piece of code during an incident response or something, I can get an above median, pretty good answer in less than 30 seconds, right? So that's just to give you a sense of how quickly that happens. If you use VirusTotal, you or your endpoint provider use VirusTotal, you will see that we actually are doing this for uploaded samples. We're running AI, we're finding things. We're finding samples that all the other AI models miss. So it absolutely does happen. Well, look, when I said earlier that we had 10x expectations, Routine reports take maybe 50 to 70% less time to create, depending on the structure of the report. This is for us, we have global coverage as an intelligence team, as you can imagine. So we do a lot of routine reporting. What is the threat to, whatever country? Again, the big, most important reporting, yes, you're still convening teams of humans to think about it and do deep research, but I think you would concede in most of our workflows, most of the work you do is fairly routine. You take the last report on whatever it was and you copy and paste it and you look for any updates. You move those into the text and then you think for a short time. You say, well, with that new news, what does that mean for the overall analytic line? And you update it if necessary. AI can do that report. So we get, maybe a 70% time savings. 95% of the content can be AI generated for the truly routine or technical reports. Those are mostly AI generated. A human checks them for errors and for anything they've missed and, make sure we actually agree with the analytic conclusion. So you still have work to do, 30% of the work, but 95%. So there's two ways of looking at that. 30% of the work remains, but it's only 5% of the text. So it's the most important critical part of the text. But you're also freeing up the analyst to do multiples of the old work, right? Several times their old work in terms of their time. Internal to Google, we have our incident response team using Gemini to write their sort of incident reports. Hey, we got a trouble ticket opened on some security issue, an attempted intrusion or whatever. Some people who do IRs are good writers, some aren't. So there's actually the quality is higher with this than with human, having them write their own reports from scratch. But much like with the Intel reports, yes, you still have to write it yourself. But we've seen it free up 51%, not of their writing time, but of their overall work time. It essentially multiplied the ability of our incident response team to do 51% more trouble tickets, same amount of teammates. And they're not really using the LLMs to do direct security work, but you're dumping your PCAP and the trouble ticket and any notes you had, all the forensics, into a directory and saying, hey, write this up. Why do we trust the quality? Well, we trained Gemini on the best samples, right? We looked back several years and said, these are the best written incident reports. These are the people on the team who are really good writers. Let's have them write this up. Training it on that means that the output from this LLM actually gets, on average, higher ratings than our human generated reports. Not as good as the best human writers, but better than the average IR person. And you're taking away a large percentage of their team spent doing paperwork. So with that, I hope you enjoyed that presentation, gave some real numbers behind these things. It's good news, bad news. Defenders are going to get faster. Studies show that if you can respond to an incident within an hour of being compromised, in terms of economic damage to a publicly traded company, it's essentially the same as not being compromised at all. So on the defensive side, getting faster, using AI tools to scan your code as you're generating it or once it's in the repository. And on offense, I think the ability to move laterally once you're in a network will really surprise people. It's fast and effective. The ability to conduct a completely autonomous intrusion, tooth to tail, you still have the multi-phase failure rate issue that I highlighted. So I hope you enjoyed today's presentation and gave you something a little bit different to think about.